We're going to review for a second. What does GCF stand for? Common factor. When we learned to do the GCF, we had a lot of work going on, right? We'd write down all the factors of each number, find which one on the list was the same. You can totally still do that, but can you also just look at these numbers, 2x plus 4, and tell me what the GCF is? Yes. What do they have in common? 2. So you would say that their GCF is 2. That means I'm going to factor out the GCF. Factoring out the GCF makes my numbers smaller, which means they're more usable or user-friendly. So to factor something out, that means I'm going to divide by it, because factoring is dividing. When I do this, like you did on your homework, you would divide each piece by the GCF. The GCF goes in front of the set of parentheses, and the leftovers go inside. What's 2 divided by 2? 1x, or just x. What's 4 divided by 2? 2. I have factored out my GCF. Aren't these numbers significantly smaller than the other ones? Yeah. So when we do problems today, and for the rest of the time, anytime I ask you to factor, you're going to have to remember a beginning step. Before you do what we did last time, you're going to stop, and what are you going to ask yourself?
GCF.
Is there a GCF? Because if you say yes, you're going to factor out the GCF, make all your numbers smaller, make your life easier. Abby's going to be my GCF friend right now. Anytime we start a problem, she's going to hold up our stop sign, and we're going to remember to check for a GCF. Fair? You have a job today.
She doesn't want to do it. I want to volunteer. I want to volunteer.
She's the only stop sign for today. But we're going to go to number 7 on our notes. And it asks me to factor completely. Remember, anytime we factor, now we start with what question, Abby? Hold up the sign. Does it have a greatest common factor, class? Does 4, negative 10, and 14 have a greatest common factor? Yes. What number do they have in common? 4. So what they have 4 in common. Here I am just saying what y'all say. Got me confused too. All right, the GCF here is 2. If I didn't notice that, don't write this down, but if I didn't notice that their GCF is 2, I'd have to come in here and do all of this work. Do you want to do all that work? No, just look at the numbers and make sure that they have a GCF. Easy. Okay? Since I know that that's the GCF, I can divide it away. It will make all of the numbers I'm working with in my X puzzle significantly smaller. So here we go. Divided away of all of them. The GCF can't just float away. It's still really important. So I'm going to put it in front of a new set of parentheses and put the leftovers inside. 4x squared divided by 2 is? Negative 10x divided by 2 is? 5x. Cool. And negative 14 divided by 2? Negative 7. The numbers that I've written in green are now significantly smaller than the original numbers. Do you agree? Yes. If I had set up my X puzzle from the beginning, I'd be having to do the factors of 4 times 14, which is 56. That's a big number. But now, what's the number that's going to go in the top of my X puzzle?
2. No.
Negative 14. That's much smaller. Agreed? So now when I set up my X puzzle with the new leftover numbers, that's what I'm using. What goes in the top of this X puzzle?
Negative 14.
What's the B?
Negative 5.
And what's the A?
2.
So we have now set up our new X puzzle using the smaller numbers. The rest of this is pretty much the same. What solves the X puzzle? Here's the list of 14. 1 times 14 and 2 times 7. If the top is negative and the bottom's negative, what does my magic number sheet say?
It's 7 and 2.
Wait, answer my question. Listen to my question. What does the magic number sheet say about a top positive, a top negative, bottom negative?
Big negative, small negative.
Big negative, small positive. Cool. And then you guys told me the numbers.
7 and 2.
But the big one is 7, the small one is 2. So negative 7 over 2 and 2 over 2. Which does become 1, thank you. And then this side doesn't reduce, so I'm going to leave it as a fraction.
And then you're going to factor.
I'm just going to write it as linear factors. X and a 7 over 2. X and a positive 1. Now I did something wrong. What did I let float away? No, hold on. Listen to my question. What did I just let float away in this equation right here?
-7.
The what?
-7.
This 2? What is this 2 called?
The big O2.
The big O2, the GCF. Can I let that float away?
No.
You got to write it down here. And now what y'all are trying to tell me to happen is going to happen. Can I have denominators?
No.
No. What do I do with those denominators? Yes. Yes, I think all of that is saying exactly what I want, where we would swing it forward. And so my final answer, my factored form would be 2, from my GCF, times 2x minus 7, x plus 1. You can't let that GCF float away. It is a part of my polynomial. Let's look at this. That was a SpongeBob reference, I know. Let's look at number 8.
Oh my God.
Abby, we're starting with questions. What are we asking, everyone? Is there a GCF?
CG. 4.
On number 8.
Oh, I don't know.
What do 2x squared, 8x?
Oh, it's 2.
It's 2.
My bad.
They're all even numbers, so they're all for sure divisible by 2. So their GCF is 2. That's what I'm going to divide out of each and every one of them. It won't always be 2. We just happen to have 2 examples in a row that the GCF is both 2. Now, I divide this out and I put the leftovers in parentheses. 2x squared divided by 2 is what?
1x squared.
1x squared. 8x divided by 2 is?
4x.
And negative 42 divided by 2?
Negative 2.
Negative 21.
Oh,
Yes.
my favorite number.
Okay. These numbers are significantly smaller than where we started. If we had tried to make an X puzzle with the beginning problem, we would have to do 2 times 42, which is negative, or 2 times negative 42, which is negative 84. That's a big number. What number are we putting in the top of our X puzzle now?
No. 14. I mean, we're 2.
Oh, what goes in the top?
She said 4.
A times C, what's A?
X. 1.
1. What's C?
21.
So 1 times negative 21 is?
Negative 21.
Significantly smaller than negative 84. What goes in the bottom?
4.
4. B for bottom. What's my denominators?
1.
Very cool. Hey, you're going to finish this problem.
Who?
Everybody.
Oh, I thought you were talking to me. I was going to say, oh.
So we have this X puzzle that we set up. We are looking for the factors of 21 that add to 4. What'd y'all get?
7 and negative 3.
Yeah, that's negative. Oh.
That's what I got as well. Or negative 3 and 7. Remember, the order doesn't matter. So here's my answer that I got. X plus 7, X minus 3.
Wait, you can only what
Did
this
you
one.
forgot your dad is coming back?
Oh, you're right. Thank you. Don't let me slip.
Very good.
What's your question here? You can't let that GCF slide. You got to make sure it's in. Look, she's already got the stop sign up. Look, we're about to start another one, and Abby is ready. What are we checking for every time first?
GCF.
Okay. On number 9, does this have a GCF? Between 3, 21, and negative 24?
Not 3.
No. Girl over here, my friend.
Aren't all those numbers divisible by 3?
3.
Okay, so the GCF is 3. We're going to divide each of these terms by that GCF to make our numbers significantly smaller. What would be my leftovers?
1x.
1x squared, cool.
And then there will be 7
Thank you, 7x's.
and then minus 8.
Very cool. You got the rest of this one. I need you to set up and solve the X puzzle so that you can factor this polynomial completely. So we set up our X puzzle. Thank you for doing it by yourself. We'd have negative 8, positive 7, and a 1 underneath. The factors that, these numbers that solve this X puzzle are 8 and a negative 1, which would be 3 times x plus 8, x minus 1. Hold on, what's up? Oh, so good question here. What if I wrote it like this? 3 times x minus 1, x plus 8. Is that the same thing? Yes. The order does not matter for multiplication. 3 times 5 and 5 times 3 are the same thing. So if I multiply these in a different order, it's the same thing. All right, you have number 10 all the way through. Abby, what's the first thing we do?
Do it. Do it.
Do it, everyone. That's what Abby's saying. All right, here we go.
Yeah, Abby.
So if you're stuck on the GCF, if you're stuck on the GCF, you might have to do this. If you can't see the GCF, you might have to make a list for everything on here and see what they have in common. If I do that, does that help you find the GCF? What's the GCF here? Okay. Can y'all finish it now? Okay, bet. So the GCF is 2. We found that by having to show the work. You don't have to show the work if you can see it. I'm going to erase it so I have the space. But the GCF is 2, which means each and every one of these I'm going to divide by 2. This would give me 3x squared minus 7x plus 2. Not always will the GCF be the same number that's my A value. And not always will it reduce out to 1. You do still have to do that division so that you have a number there. Okay? I set up my X puzzle. What goes in the top?
6.
What goes in the bottom?
-7.
What are my denominators?
3.
Cool. Since the top is positive and the bottom's negative, that means both of these are the same sign and they're both negative. -1 and -6 solve this X puzzle. -1 times -6 is 6. -1 plus -6 is -7. This side reduces to -2. Remember, order doesn't matter. Now, when I write down my factors, I have to remember my GCF, and I will write down the exact linear factors that I have. After I write down that line, I have to remember to do what? Swing my denominators forward. So wherever you have your denominator, it goes to the front of that linear factor. If they both have denominators, you swing both of them. This is 2 times 3x minus 1, x minus 2.
So you basically.
Or backwards.
Got it right.
The order does not matter.
Again.
What's your switching the denominator?
No, like, okay.
You just got that?
You see how you do the, shut up. So you see how you do the 3, like, at the top, when you start doing the 2 thing, you see how you put the 2 and then your parentheses and then the 3x squared and that stuff?
Mm-hmm.
But when we got, like, the answer part,
Mm-hmm.
it's like the same thing except you don't have the 7.
That's correct. Because this is pre-foiling. If we were going to foil this blue equation down here at the bottom, she's saying these numbers look really familiar, which is true. Sometimes they'll look more familiar than others. But when we foil this, 3x times x is 3x squared. We do the outside, the inside. Those are x's. They make -7. Then we do the last. -1 times -2. It's a +2. So we've just done FOIL backwards to factor these equations. Before we're done, you have to ask me 2 questions. We're going to stare at each other till I get 2 good questions about this whole process. So look at them, find a question, and ask it. Abby's first question was, what is this? And she held up the sign. So every time you do this, what are you going to check for?
Greatest
Hold on.
common factor.
The greatest common factor. The second question I got is, why don't I show this part of the X puzzle anymore, where I do this? Do you have to show me that work?
No.
If you can do that part in your head, you don't have to show it to me. In fact, I'd rather you do it in your head. But if you need to write it down, and sometimes you only need to write it down when the numbers are big and you're like, ooh, these are big numbers. That's fine. Write them down. But if we can do that part in our head, that's what I would rather have you do.
Why do you have to use the X puzzle?
That's the process for swing and divide. If you can factor another way that doesn't use an X puzzle, I accept. But this is the way we teach here with swing and divide.
Show me your work.
Yeah. There's still a bajillion ways to factor.
Like foil.
Like foil. So, question. If I gave you this worksheet, and I will in a second, I'm going to explain to you how we're going to do it. And you saw this first question. Before you did it, what's the question you ask yourself? Abby?
GCF.
We ask ourselves, do they have a GCF? For number 1, do these have a GCF?
1.
No.
It's technically 1, so we don't care about 1. So, no, it doesn't have a GCF. Will I have to do the step we learned today of factoring out a GCF? No. So to factor this, I'd go back to what we did last time and just start setting up my X puzzle. But if you saw a question like number 9, does number 9 have a GCF?
Yes, it's 2.
So we have to start by taking out that GCF. Because otherwise we're finding the factors of 216 and that's gross.
Number 11 is 5 and so on and so on.
Very good. So always ask yourself Abby's stop sign question of, do we have a GCF? Here's what we're going to do.